Let's take our seats, please. Please take your seats. Everyone around the booths, please come and take your seats. We want to start. We are running good with time in the early part of the morning. We don't want to be late. So I want to start our demonstration from a company called Bless. And the person representing them and giving us the demonstration is called Caspar Kundat. Please, Caspar, raise up for recognition. Let's give a hand. Caspar has a very long CV, but I'll just pick some briefs. He comes from Switzerland. Caspar comes from Switzerland, but he's resident in Kigali, Rwanda, since 2010. He has been in Kigali for 13 years. Caspar holds a master's degree in geography and IT from the University of Zurich in Switzerland. He obtained it in 1988. The youths, I have to emphasize 1988, you know what it means. not recent. His first job, by some coincidence, was with United Nations Environment Program, UNEP, here in Nairobi in 1999, where he worked up to 1990. Then he moved back to Switzerland, and he worked with Esri Switzerland from 1992 to 2010. In 2010, Caspar moved to Rwanda, and he became the founder and director of Esri Rwanda, which he ran up to 2019, after which he is a consultant and now representing Bless. So Caspar, welcome, and give us the demonstration. Thank you.
Thank you so much. Good morning, if it's still morning. I would like to start with thanking Rcmrd for this beautiful conference, the big stage that I'm getting. And I have to apologize, the title was training, but this is not really a training setup. So it's a bit more of a demonstration of what Place is doing and where we see the value of data, challenges to data. Later in my slot, my colleague Pauline will join, and she will show you on her computer live the demo part or the training part. She's also at the Esri booth out in the other tent. If you want to have more hands-on and engage more, I'm still around today, tomorrow. Let me start with the presentation here. I will be talking about Place, the company I'm representing, and then we want to go to the next level. That's what we heard, all of us. In my opinion, that has something to do with the value and sustainability of spatial data. Remember, we want to bring it from space to communities. Communities depend on us, on the professional, that this is not a one-time effort, but it's something they can rely on, maybe today and in a year's time again, when you want to monitor, today is nothing. I will talk about the Place model, the products, and the data analysis and the insights that can be gained from this high-resolution area and street imagery. I promised to Rcmrd that there will be time for Q&A. I hope the moderator will remind me of my promise and also cut me short if I should talk too long. Place is a global non-profit technology organization. We want to help governments to map their urban landscapes. Note there is a shift in geography from what we heard before. We were talking about regional data sets, about sentinel data, continental data sets. place is concentrating on sizable areas like Nairobi or smaller towns, but it's about urban landscapes, not about entire countries. Our vision is to be the most compelling data trust of mapping data for the benefit of people, community, and the planet. The slides were existing before we had the slogan for this conference, so you know we also talk about community, and we want to make time affordable and relying mapping data available for our government partners and the community members. The company is built on experience. We going through the Omidyar Network for Property Rights Initiative from 2013 to 2020, and we became place in 2020. Some of you may have come across some of the organizations. I would say we have a shared heritage. Rcmrd has been in similar places, and I'm sure many of you as well. If we want to take it to the next level, we know, and if we want to do it effectively and bring space to communities, we need to understand where we are coming from. Otherwise, it's just jumping to another place, and it doesn't mean very much. This is why I would like to start with looking back when thinking about the next level, and I want to share with you an article I found in The Economist. You don't need to be able to read all the details. That was published in 2014. The compelling title, which raised my attention and also my which annoyed me, there is no data in Africa. I thought a moment about that. I was 4 years in Kigali by then. Like many of you, I struggled to get data, but there is no data in Africa. That's simply not true. I think you can't say enough how much data, how much money has been spent and effort and time by specialists like you, by government, by donors, to create data. International organizations and NGOs were involved, and investments are made and were made constantly into data. Some are made in projects which were creating data as a collateral only. Say, a surveyed terrain for a new road creates data on the land to the left and to the right of the planned road. And some projects, they had the specific purpose to create data. Say, aerial imagery, which was flown by Street Survey as the foundation of the cadastral system of the Republic of Rwanda. So there is data in Africa, but unfortunately the end of many projects means also the end of the data itself. It has been collected for the data, the reports have been accepted, and where is the data now? Or, as you see on the picture on the right-hand side, I have to say it's an Rcmrd member country. That's one of the doors I tried to get GIS data from, but it was locked the whole day. We heard that before, and I'm not certainly not the last one to say it. Resources are wasted, the same data is captured more than once. There is data in Africa, but more often than not, we are, or you are, not able to access it, even if you're entitled to access it. You have to ask yourself, why is this the case? And how do we get to the next level if we are missing the data? Are we lacking powerful software? I don't think we can say that after what we have seen by David Gadsden. And yes, I've been with Esri for the better part of my life, but I also realized there are many other software solutions that give great value if they only had the data. When I hear about the data cubes from Digital Earth Africa, it's there, and they have an ecosystem, they find the data, it brings value, so I don't think it can be the software. Are we lacking in skilled staff? That might have been true when the Rcmrd conference had 100 attendees. But now there will be student housing, and we are 800. That should be enough to get started. Are we lacking open data policies? We talked, some people or some presenters talked about open data. And I wanted to consult the open data barometer I was quite fond of a while ago. And found out that the last open data barometer was published in 2017. For some reason, that doesn't seem to be so much of a buzzword anymore. We dreamed in the, say, 16, 17, we dreamed that open data would solve all our problems. I'm not sure if it does. Rwanda published a data revolution policy in 2017. And the data policy says data is open by default. I thought, wow, the doors will be open and I will be able to get all the data that I need for government projects. They are respecting privacy, security issues, but data should be open. It's still not the case. We can't access data, and I like a word or a citation from His Excellency, the President of the Republic of Rwanda. He was asked by a journalist once, what is good governance in one word? And he said implementation. Yesterday we heard about the linkage between science and policies. And we make, and many countries made fantastic advances in the policies. To get data, the policy alone is not good enough. We also need implementation of what this policy says. And we may have to adapt the policies because as we try to implement, we learn more and the policy may not reflect the latest. And by the way, here, this open data barometer showed very little impact for most of the countries on a scale from 1 to 100. Rwanda scored 3 with the open data policies they have in place. It seems we have still a bit to do. Do you think we need more AI? I'm taking back that question. What do we need to get to the next level? Or what prevents us from opening up the spatial data ecosystem even more to the communities? This is where place has an answer, and I don't want to get across saying that this is the only answer. It's a complex issue. You are mostly, all of you, thinking about that. There are technological answers, there are staffing answers, but we say that a fundamental problem lies in the fact that formerly governments, that's the slide, the part here, they were creating spatial data, and more spatial data is taken over, or the creation of spatial data is taken over by private companies. Governments are challenged to create the data. Just think about the National Mapping Agency. I'm coming from a very spoiled place, Switzerland. We have a National Mapping Agency. They are publishing maps. They do it every year. They have the funding. And all we had to pay, we had to go to the shop and we had to pay the printing costs. In the meantime, the digital data even became free of charge. Switzerland has the means to have a plane, to have staff, to have an entire organization who just does that. And we can imagine that this is not the case for each and every country in the world, even though many would wish to be in such a position. Later, private companies came. And when I had difficulties to explain to my relatives what I'm doing, GIS, eventually I had to be okay with saying I'm doing something like Google Maps. As a geographer, I hated this. But if you talk to your old auntie, either you can hate this statement and not make it and try to explain and fail, but Google started to become a kind of a private mapping agency. It seems that you get the data for free, and we should not underestimate what we are getting from them. But we are paying with our privacy. We are paying by adhering to their schedule of when they want to do it, and we gave it out of our hands. So suddenly the economical basis changed, and it became from a public good, the maps, it became a private good that is given to us at the way the private company wants to share it with us. So we believe that at the basis of many of the challenges, it's the economy. De facto slogan of Bill Clinton's 1992 presidential campaign was, "It's the economy, stupid." That was one of the main reasons that he won the presidential election, because he addressed what was a major problem in the US in the early 90s. And I'm a geographer. In all my studies, we never talked about money. We were in love with technology. There was not enough GIS you could be doing, not enough time you could be spending. It was cool, and I still like it. But somehow you have to think about money. And that's something, a word to the young audience. You don't have to like the economical part necessarily, but keep it in the back of your mind. Often it influences what you want to do. Often it influences how you want to do it, and it prevents you from doing one thing, and you're surprised that a technologically inferior idea suddenly wins. Then it's mostly the economy behind it. We are trying with Place to change the narrative and to address the market inefficiencies that prevent governments from making their mapping data and creating new mapping data. I know this sounds a bit theoretical, and I'm not on a World Bank Congress or another banking thing, so let's skip these slides. If you retain one thing, think about what money is paying your data and what money is needed to make your data updated. We have beautiful projects paid by the donors. By definition, donor money is for a one-time off. Don't expect them to finance the update of the data. So there is a lot of economical reflections that need to go into the data capture. We believe that it's time for a third party to provide a solution to these market issues around data, a market or a solution which is not motivated by profit only and can be trusted by everyone to solve these inefficiencies. And you will see more about this little wheel that we are presenting here. We want to leverage the Place network power. We want to have local support. We want to scale and work with local companies. We want to create jobs for the young people, be transparent and accountable. We are not for profit, and we want to make data affordable, accessible, and financially sustainable. Open data said it should be for free or at nominal costs. If I said before the economy plays a role, things that are for free are often considered to be no good. That's a quote by Einstein. Maybe data cannot be completely for free, but it should be very affordable in the least. And if this affordable money allows an organization to maintain it, we believe that's the right way to go. So our model works as follows. First of all, Place wishes to sign an MOU with a government agreeing on the responsibilities for place and for the government to get certain mapping tasks. And remember, we are offering to map urban areas on the African continent and in the Caribbean. So with such an MOU, after that, place provides personnel to train and develop capacity on the ground locally to fly drones. If the capacity is already there, we would want to team up with such a company, and we know there are many flying labs. There is a company showing here having a booth. So we don't want to reinvent the wheel, but we would be conducting with such a local company the initial flights. We are collecting the imagery at our costs, and we aim to collect aerial and ground imagery every 12 to 18 months, depending on equipment and resource availability. We will be processing the imagery in the place labs and check the data, assure that the quality is comparable about the different geographies we want to fly in, and put the imagery into the place trust at no cost to the government. If we move to the right side of the slide, all data produced in this way is owned by the government with whom we have an MOU. So if we are signing the MOU, the government is the owner of the data. The government is allowed to do whatever with the data they wish to do. However, we, as the place trust, would have a right to share the data also with our members. Our members is our community. So the members, by paying a membership fee, allow us to offer the services for free to the government. They can have a look or they can use the data, but essentially it will belong to the government. We are raising our funding from our community through contributions and commercial data licenses. Place consists of a community, our members, a trust set up in the UK that holds the data and has the legal backing, and the place labs where data is being processed, and you see that this down to the ground real work things, they are done on the African continent, in Yaoundé, in Accra, and in Kigali. Or they will be done. At the moment we are not fully operational in all these places yet. Place offers two principal products, Place Ground and Place Aerial. So if we have to use this analogy with Google again, Street View and the aerial imagery, but our aerial imagery, as you will see, comes in at a higher resolution. I can show you a short video on, I think I can, yes, on how we are collecting ground data. That's in Kenya, that's in Sierra Leone. So we have teams, and that should be local companies, local teams, that collect the street view imagery or the ground imagery, and again, place labs will then afterwards process this imagery. When we continue, the aerial imagery is a 5 centimeter high resolution imagery. You have here the comparison on the right hand side, a typical Maxar or Google image, and on the left hand side a place image which we collected using drones on a Caribbean island, one of our first clients. Once you have the two, remember this data is handed over to governments, they can use the data in whatever platform they wish. We've been doing some tests with Esri, and you see here in a second video how, yeah, it's playing, I think, how the two the map and the street view are aligned. You see on the left-hand side in the map how the car moves ahead. You see the green dots in the image inserted, how the two places or where the pictures were taken. You can see the angle the photo was taken. So you have everything that Google does, mostly with satellite imagery. You have higher resolution aerial imagery, and most of all, you can do whatever you want with it, because it's not just an offering view only in Google Maps. We think that there will be way more analysis tools that combine the aerial image with street view. I'm engaged in a project for the Rwandan Revenue Authority on the computer-aided mass appraisal for property values. We struggle with the third dimension. We get building footprints quite easily out of satellite imagery. We don't even need drone imagery for that, but we don't really know how many floors there is. Imagine we had also the street view. Then suddenly it would be much easier to assess the value of a building remotely and check whether the self-declaration has been kind of correct or not. So this is the area, or these are the offerings of place. Aerial and street view combined, and this every 12 to 18 months renewed at no initial costs to the government who has signed the MOU. I think I preach to the converted when I say talk about the endless possibilities that such data offers. You've been engaged in various analysis techniques. You're working with Rcmrd on this. The bottleneck seems to be data most of the time. And place tries to find an economic model to help you have a constant stream of new data. I believe in some rural areas it may not be, well, if they are not affected by natural disasters, but in areas which change less, you may not have to have new data every 12 months. But African cities develop at an incredibly rapid pace. That's where, in Kigali, we always used the 2008 aerial imagery. And then we had another look at Google and saw what changed, but we couldn't overlay that necessarily. You have to have new imagery, at least for the urban spaces. And that's where we would like to offer an alternative approach. Is this now a nice idea, or is it a reality? I'm convinced that's a nice idea, and it slowly becomes reality. You have a few dots. The yellowish says where we have already collected data. We did some trials in Kenya. We have collected data in Ivory Coast, in Abidjan, Sierra Leone, and Accra in Ghana. We have flown some in Togo, and we have a MOU in place and have just completed the data capture. Turks and Caicos and another Caribbean island, Antigua, is to be flown quite soon. The Caribbean islands are beautiful for us. I haven't been there, by the way. They are quite small, and they allow us to it's like a bit a proof of concept of the technology. And that helps us to be ready for larger areas. We've been talking with several African governments already, and we wish to continue the dialogue, discuss with you whether that's an offering. It's a new idea. You're more than welcome to challenge the idea and tell me why that can't work. It's important for us to know that, but this is the way we would like to go. And Pauline, if you can slowly get ready, it's not just PowerPoint. PowerPoint is a famous first version of software always. Pauline will show you on the basis of the of data from Abidjan what she's able to do with Esri software technology. I said I don't consider technology or software to be the challenge. Pauline, take it over and show us what you're able to do. After Pauline's presentation, we will have time for questions and answers, as many as you want to do before lunch. Thank you.
Thank you, Caspar. I'll just take the next few minutes to walk you through how you could make use of imagery such as the one from Place. So before I do that, I'd just like to touch a bit on the capabilities that are there within, excuse me, within ArcGIS when it comes to being able to work with imagery, that is extract the information as well as analyze it and derive insights. So over the years, we've been able to build the capacity to be able to come up with insights or information from imagery. I think previously, many of us who've been in this industry for some time, the only way you'd be able to extract this information was to manually or to actually digitize this information over time. So now we have the ability from imagery to extract information, predict what is going on with the data as it is now and as we progress over time, find patterns and clusters, and be able to get insights again over time. So all of these capabilities are enabled by machine learning that's now embedded into the ArcGIS system. So the steps for going through this, which we'll actually walk through in the demo, will be, the first thing is to prepare your data. So you get the image itself, but you need some other additional information to help your model to understand what is going on, or when you have the image and you want to get insights from it, to get guidance of what to do once you have the image going through the model. So once you get you prepare the data, you train the model. That is, we have the tools that are in there. So these tools have been built using Esri technology, but beyond that, we've leveraged our capabilities to have open deep learning libraries. So we have a lot of work that has been done that is openly accessible by many organizations, by many communities, and we've been able to embed these capabilities within ArcGIS. So after training the model, we do inferencing. So this is the point where we keep on running the model to fine-tune its performance, and then finally get the result that we need. Oh, sorry. Thank you, Lorianne. Let me just try and project it again. Yes, and get the information that we need. And then after that, we will derive insights. So the main purpose of us doing this is not just to say that, okay, now we have buildings, or now we have roads, or now we know this is the kind of land cover in this place and how it has changed, but what kind of insights can we derive from that? So I'll just touch on that a bit. So with that, yes, we have the tools that support that within Esri or within ArcGIS. And we also have capabilities that have been put in some of the tools or at some of the layers that we have available within ArcGIS. So with that, I'll just switch over to the demonstration quickly. So in this case, because these capabilities are available across board in the system, where, as I said, we have them accessible as content that you can access. You can access some of these libraries through our platform. You can access it on the desktop application. You can access it on web applications we have, and so on. So in this case, I want us to look at the scenario of using place imagery to do a bit of deep learning analysis. So this is just a base map I have for Abidjan, but if I add the place imagery there, you can already see that it provides something that's a bit better in terms of understanding what is going on in this area. So place imagery is high resolution. It has a number of bands that you can use to do your own analysis and so on. So the capabilities we have that will support us are part of the geoprocessing tools we have. If you come to analysis, tab here on the ArcGIS Pro, which is our desktop application, you can access the different tools we have. And these tools have been powered by an extension we have known as Image Analyst. And again, within that, hopefully if you have any questions, we can discuss further on the booth. You'll have access to some of the tools that support different kinds of analysis. So if you want to do change detection, if you want to be able to extract information, do classification and so on, you'd be able to do that using the tools that are available here. So if I focus on my deep learning, based on the workflow I'd shown earlier, the first thing we'd want to do is prepare our data. So I'll use a tool known as export training data, train the model, and then finally detect objects. So I want to detect the buildings within my image. So to train the deep learning model, the tool, it's a script that has been converted into a tool. So I would like to, should be export training data. So in this case, I'm looking at my raster. So it's able to pick imagery, which is available. So it could be an image data set. It could be an image service. It could be a mosaic data set. So provided it's imagery that has bands that would be able to, you could use for that, then you're able to add it. You can specify the folder where you want this information to go. Just trying to see if it can pick it. Okay, it's not picking it. Let me just navigate to that particular folder. So I'll use my, I'll create a new folder. Sorry about that. I'll leave it as new folder for now. And then after that, I can leave the parameters as they are, then change my metadata format. So it means that when this information is created, that is my training data. I want my stacks of images to be created and for them to be labeled based on the tile for each image. After that, you'd need to change the environment and customize it to run this particular analysis, which can leave as default, or you can make updates to it. Once you run the tool, within the folder, some information is created. So this is the data that you'll actually use to explain or to try and help the tool to understand what is in each chip of image, what information is there, and the corresponding metadata for each image. So you can see it just created chips for the image that I had across board. So first we have the images, then we have the labels. I'll just open one of the labels. And the label is saying for each chip of image we have some information that will advise the tool. So you can see the parameters that are specified there in terms of width that there and the extent for that chip. So after that, I will train the model, which I will just come back again to the tools here. So for training the model, it means that I'm taking my training data, the chips that I had prepared before, as you saw. Again, I need to navigate to this. Sorry. So I have my model there, my chips. So I'll just select that. Then when you have the epochs, it means that how many times do you want this model to keep on running over the images so that you feel satisfied that the output is suitable or it's actually generating the output that you want. So that's just what it basically means on the number of times, the epochs, the number of times you want this model to run. So once you're done with that, you run the tool, you get some insights. And one of them is the performance of how this model has run over the number of times you ran it to understand how close is it to predicting the buildings within the image. So the purpose I was running this model was to extract buildings from the image. So you can see that from running from the first batch all the way to the last one, you can see we are getting closer and closer to predict the buildings in the image. And beyond that, if I do the comparison of ground truth versus predictions, then you can see that it's trying its best to pick the buildings. I hope it's coming out clearly. So you can see even in cases where maybe for that particular chip, a bit of the building is showing up, it's trying its best to pick this information. So on that bit of being able to train that particular model, you may need to keep on fine-tuning the parameters so that you get something that's close to accurate to what you intend to get in the long run. So that's the second step. And now we'll go to the final step, which will be to detect our objects or to detect the buildings. So again, looking at that particular raster and then getting the model that we finally created, which once again, okay, it's getting close to. So I'll select the model. So all of this information is just taken to folders that exist. So you can select the model there, and once that is done, it will try and place in the model itself. Let me just try and do this again. So you can place either the model package or an S3 model definition file. So one of those two would actually work, which for some reason right now it's being a bit hesitant. So you can use one of those two to actually run the model, or the other alternative you can have is use models that Esri has provided as part of our content. So one of the content providers we have is the Living Atlas, and from that point you can find different kinds of data sets or different kinds of content. In this case, we have we have deep learning models that you can take advantage of. So for example, if I chose models tied to getting building footprints, I have different options I could take advantage of. So in this case, I have building footprints extraction for Africa, which is a deep learning model specifically tied to understanding what is the kind of reflectance you'd get from buildings or structures within Africa. So that's also in the format of DLPK, EMD, which you can try and add into your model and let it run. So it's an online file which will take a bit of time to try and reflect so that we can see the parameters here. And once that is done, you should be able to get arguments that you'd be able to update, and then finally be able to run this tool and come up with the building footprints themselves. So I was able to do this before, which I had anticipated. Maybe this might not work out as I'd hoped on screen. So I came up with the final footprints, which you can see here, which were created. We had the training data set that was on this side. Then I was able to run this model and finally come up with the footprints. So these footprints, as you see, it tried its best, the model, to generate some of the footprints that we can see for each of the buildings that have been highlighted within Côte d'Ivoire. I wish to emphasize that this is an iterative process for you to be able to come up with such outputs. And beyond that, when it comes to getting insights and sharing out information, Once you create your footprints, you can share it out as a web layer, which can be added into a web map, which can be added finally onto a web application. So in the case that we have here, we had our building footprints that were created, and then we were also able to generate roads from the same image, which you can see it's here. So some of the insights that we'd want to see is, what is the buffer for a particular road? So for instance, if there's some buildings that are close to or within the road reserve, we'd want to highlight which buildings are these, and you can see from the buffer itself, which is predefined to say this is the road reserve, then we will know which buildings will be affected from that. And again, if we run our analysis, we can see, or this can be selected for us to see, which buildings actually fall within this. So if they need to be compensated, if they need to be notified that they're actually within a road reserve, this will be possible because we've been able to extract this information from a current image using the deep learning tools that we had. And then beyond that, we've added it into a map which allowed us to perform these kinds of insights. So that's just an example of how you can go through an entire workflow of using analysis on imagery. So I think with that, I'll just hand it over back to Caspar.
Pauline, before you completely go, thanks a lot. Impressive. This is things that I haven't seen in ArcGIS when I was mostly working with it. I would have one technical question. When you created these red buildings, can you then use them, edit them, and use them again as training data? We have seen many very good results, but in some places, certain buildings were picked up less well. Could you then complement the training data?
Yes. Thank you. So yes, it's possible to do this because, as I mentioned, it's an iterative process, meaning you can enrich your original training samples, and then you can run through the process again, just to keep on refining the tool, as well as the scripts themselves to be able to pick out this information more accurately. Yes, so it's possible.
Thanks a lot, and maybe you stay somewhere close by or keep the mic. I would like to open the floor for questions, be it on the more theoretical part or be it on the part, the very practical part that Pauline performed. It was supposed to be a training session, not a presentation, so I really count on you to have a few questions. Who starts?
I can start. I'm here. Hello. I'm here.
Thank
Okay.
you. Sorry.
Good. Yes, my name is Kwame. I'm from Ghana, and I am excited about what you are doing in Accra. So my question is, how do you get people to participate in helping you collect street map images? If that is possible, would you allow a private entity or someone, a volunteer, to support in doing that? And
yes, continue.
And what is your strategy, perhaps, in getting researchers to help build tools for analyzing some of the images you also collect?
Thank you for this twofold question. For a very practical reason, we want to work with local companies. When this model takes off, we are not able to send expatriates to all the places, and they are not affordable either. We are trying our best. We listen to advice to identify local companies who are technically capable. We have quite strict guidelines how the products have to be, well, the quality and the specs of the technical output, and the company has to be able to deliver that. We have tools to check that, and we would probably engage in an initial phase with the company, do a test, see if they are able to deliver the quality. and then sign a contract. Obviously, since we are only working on a MOU with the government, we would expect the government probably to help us in selecting such a company, and the governments might also have a say in whom we are selecting or not. But for us, it's the quality, and it should scale. We need private, local, or we need local technical support to get the data in. The second question about research. PLACE is delivering the data in a not very much processed format to members from a research community, from research to very commercial. And we trust that there is enough skills, enough software, whatever you need out there. We don't want to compete in doing research in, say, extracting building footprints. We would like to enable local companies who become our members to do that. They know better what the local communities need in sort of derived products. Where we see the market inefficiencies, I've seen that so often. We have a Carnegie Mellon University in Kigali, and they come with these beautiful data analytics ideas from the US, where there is a lot of data. And then students want to find the next pizza shop, but there is no street data in Kigali that you can leverage. These are things that we would like to help, that the data, creative ideas or research can be built on, can happen. And we are not doing those, but we would invite you to become a member of PLACE. Yes, please.
Thank you very much, Caspar and Pauline, for the excellent presentations. So I was wondering whether there's something I'm missing from the business model you present, because it seems to me a no-brainer as to why government should take it up rapidly. So the fact that we don't have all governments signed on the contract, I don't know whether it's you delaying to offer the contracts to them, or there is something that is holding them back. Because it would appear to me that if you're offering, giving these images free of charge, annual updating, and all you do is, opening the doors, we should be having all the 55 countries on the continent already having an MOU with you. So what's holding back, and how can we help? Thank you.
Dr. Emmanuel, thanks a lot. May I offer a provocative answer? You're advancing a very much Musungu statement. That's mine. I'm also asking myself what's holding back the whole thing. On the other hand, I also understand there are concerns about security, national sovereignty, and we have seen a few cases where this wonderful offering, you want to put it in quotes, of free data, of course a government wants it. The second part, that it would also be shared with PLACE members, of course they don't want it. And for us, we have to be able to mobilize membership money from our members, otherwise we are not a donor organization, and we cannot fly for free, we cannot collect the data for free. We try, or we will. It's not that just anybody could become a PLACE member. We are quality, or we are checking them. They have to sign to the Locus Charter of Ethical Use of Data. We are aware of issues there. And I'd love to hear more from people who are very skeptical about the model, because, say, at the surface, it looks very convincing. And when you say, what can you do? I appreciate if you want to help us with promoting the model. More arguments that speak in certain views against it. And then a last remark, we may not be fast enough to scale. We started, we have not knocked on all the doors. That's our fault. We are delaying sometimes, but there is an MOU. We can send it out. We can discuss it with willing government partners. To me, it's a convincing model, and we would love to see as many of you sign up as possible. We are not saying that we solve the African data issues. We are happy that at another scale level, there is a Digital Earth Africa. We are happy that Madame Phoebe was talking about GMS Africa, about the national spatial infrastructures, something that was close to our heart and sounds very old-fashioned now, but is still not there. It's all these efforts that are needed. Satellite imagery and ground imagery does not solve all the problems. But there is a lot of progress, and if we can work together to get data availed at a more regular space, we should do it. And something I wanted to mention earlier, I said much of the data is lost at the end of the project because donor funding runs out, there is no server to put it on, etc., etc. If you're ever in such a situation, remember the promise of David Gadsden this morning. He said, bring it to us, we host it on Africa Geoportal or on ArcGIS Online. My experience with Rwandan geoportals that I was able to co-implement with government partners was that we spent 80% of the money on getting the data right and on training people. 20% we paid for ESRI licenses. If you lose the licenses, that's not so bad. If you lose the data, you lost 80% of your entire project. And David offers to host it. That's better than losing, and I'm happy to engage more in this discussion. Is there another intervention, another question right here in front?
I am Bruno from Uganda, and my question goes to Pauline. In the data preparation stage, I would love to hear, how do you handle the detection of the outliers? And in the event that the model is up for testing or training, which percentages are we looking at? Are we looking at 70-30 or 80-20? And if so, can you give us live examples where those percentages have been implemented and then the accuracies attached to them? Because yesterday, one of the key issues we were taking out was, as scientists, can policymakers depend on our data? Thank you very much.
Pauline will need a mic, or do you want to come up here to answer?
Thank you for your question, and apologies for having to come back. So I think for the accuracies themselves, the question that you had, what normally happens is most of that is balanced through the part where we were saying that when you're training the model, which I guess it's about to pick this up. When you were training the model, there are some definitions that you had specified on that particular tool. So that's where you tend to apply the accuracy of how much, I don't know where the question came from when I was, so I'll just address directly. Oh, thank you. Thank you. So as you're coming here to train the model, you see, when you specify the maximum number of epochs, what this happens, how the tool has been built, it keeps on checking and checking. First, the exported information that you had, and secondly, the actual entire image that you have. And it keeps on rechecking, making sure that for each pixel value that was there, it's assigning the pixel the right location, or the right value, or the right estimation of knowing that this is actually a building and this is not a building. So you might find that there are cases where the top of a building appears like a road, where you find their similarities and so on. So when you run this tool, it checks based on how it has been put together. And the best part about the tool is you can also adjust the tool to redefine how you want it to go about collecting this information, either through the parameters that are here, that is the model parameters, or beyond that, when you have access to the script itself, you can try and make changes to some variables. So it doesn't say exactly what would be like if it's 70, 30, or anything else. The things that you want to achieve as you're running the model is for the metrics themselves, this orange line is as close as possible to the blue line. We have had cases where people have extremely powerful machines, and when they were trying to do image analysis over a large area, for it to keep on running and running to have it closely match as possible. There are cases where you can have very, very highly accurate exports. There are cases where it's not as highly accurate, but it's a safer bet of accuracy. For the bit on where this has been used, one of the strong use cases we have for these models was the case of, there was a refugee camp in, I think it's Myanmar, if I'm not wrong, which again, I can share with you that information at our booth. So what happened is, they have a huge camp of refugees, and they're trying to map where the tents are and try to improve the distribution of services, sanitary services. So they were able to quickly map this information, especially for the extents that probably you think it's within the camp itself generally, but there's some people who are a bit beyond. So they're able to quickly map this information and immediately extend the sanitary services. So I know that's where they were able to do this in a highly accurate manner. Yeah.
And on use cases, I can add that currently my successor at Esri Rwanda, Jean-Pierre Gatero, has a contract with the city of Kigali, where he does every 3 or 6 months identifies illegal new constructions using the same model. I'm happy about the optimism of the use in AI. I'm an older person, and I would always be skeptical. Do a visual check. Still, regardless how good the values from Pauline are, I had an extensive look at the Google and Bing maps for Africa, because we struggled in this taxation project in Rwanda to get the building footprints right, for which we paid quite a bit of money. And there were challenges in all. Some picked up the small houses, apparently the training set, but then not the Kigali Convention Center. Look at places you know. Don't trust the model blindly. And if you talk to the bridge or to the link back to politicians or decision makers, I think it's your responsibility as somebody who is affine to technology to translate that. And I'm pretty sure we heard something of that sort yesterday. You have to translate the results and make them understandable. And this is not something that AI is taking away right now, at least not from my perspective. Do we have more questions? There is somebody here.
You have about data. So I think in answering my question, something came up. How can I, from where I am, reach out to your institution and access the data? Or how do I access the data? That's one. Then to Paulina, you spoke about, you showed us all of this, and you just mentioned there are some raw codes for doing all of this. How can a researcher or a student reach out to you or have access to that to build skills on that or to actually be effective?
The question about the data, you or your institution will have to become a member of PLACE. I talked about the MOUs, that's on the data production side between PLACE and the government. On the community side, we want to check you as a client. You have to sign that you're adhering to ethical standards, because that's something we promise to the governments. We are not giving it, say, to Al-Shabaab or some really difficult type of clients. And governments must trust in us that we are not doing this. And depending on the way you want to use it, when there is a commercial use, the fees would be higher. If it's research only, we are just setting up the fee. There would be nominal fees per year to access all the data. Pauline.
Thank you. So for our case, we have various ways of being able to build capacity. So it could be through self-paced learning, or it could be through attending training. So if it's self-paced, we have some online resources that you can take advantage of. One of them is known as Esri Academy. And from that point, we have multiple courses that you can access freely. So this course, once you have access to it, it could be a web course, it could be an actual lab where you do have hands-on experience, or it could be like different formats, basically. So you have access to some of these lessons. Another aspect that you have accessible through Esri Labs is, through Esri Academy is the MOOCs that we have. We actually have a MOOC on spatial data science that touches on this kind of training, especially on deep learning and so on. And finally, on the self-paced, we have a site on our website, which if you just search for Learn ArcGIS, you'll have access to tutorials we have that also touch on this. For instructor-led training, we do this through a number of networks. Definitely one of them is Regional Center, the Training Institute, where they train on GIS, and spatial analysis is a component of that. But we also have our distributor network, our partner network, which you can leverage locally to go in for training and get additional support for training beyond what you will get under self-paced online training. Yeah, thank you.
Thank you for the question so far. I insisted that it should be something interactive. You made me happy. It was or is already interactive. I don't want to cut you short. You're defining the timing, or maybe the moderator will stop us and throw us out all. If there are more questions, don't hesitate. Well, there is. That's fine. Please.
Yeah, thank you for the presentation. My name is Simon Onywere, a professor at Kenyatta University. I've just been reflecting a lot since you made the presentation and wondering this high accuracy mapping and the aerial photography, where do we part ways? At least from my old learning, in cartography, there was a need for some kind of a process that will help you place beacons of boundaries for us to be able to determine that this is the location of this building and this is the space this building will occupy. I'm just wondering with this mapping, which is not really following the principles of Nadia, vertical mapping, how do you use the model to help the people who now need the government you are talking about? The government will not need the data, it will help them locate boundaries for ownership purposes and other things. I'm not quite clear how this comes in the context of the accuracy that is desired in the mapping process.
Thank you for the question. The moderator tells me there will be one more question after I answer this one. So the question, you'll have to get me also later on. The first one more question was back there. And if you allow me, the gentleman with the red, sitting there. That's the first one I saw. Sorry for being partial. And let me answer that question about property boundaries first. Place would like to deliver as good as possible data for many purposes and trust that local organizations would be taking up and do the work on the ground. I was assisting in a project delineating boundaries for a cadastral project in Benin, and there we had to fly the presumed owner, engage in discussions and lay out the boundaries of their properties. That's one way to go about. If you use technology, if you have the traditional surveying equipment, such an image is a wonderful quality assurance measure. Have the surveyors been there where they have to go? The boundaries, I don't think it's something you get on automatically. But the imagery is a great help. Rwanda did a beautiful cadastre system. Dr. Emmanuel can tell you the details. I'm just an onlooker, but it was fit for purpose. They captured all the parcels at something like $6 or $7 per parcel for 13 million parcels, using trained people to delineate it on aerial imagery at 25 centimeter resolution. On a drone image, you would see a bit more, but you wouldn't fly 26,000 square kilometers with a drone. Fit for purpose means take the type of input you really need, and for a city where it's dense or the informal settlement, we are seeing there a satellite image is not good enough. And Pauline showed even in more challenged areas, we have seen the differences between the small houses. So combine good data with a fit-for-purpose approach for what you want to achieve. And get me afterwards if that wasn't good enough. I take the last question.
Okay. Good afternoon, everyone.
Good afternoon.
My name is Luis Wambua. I'm a student at the Technical University of Kenya. And I'm also into machine learning and deep learning. And I want to thank you for your presentation. My question is, do you guys develop like more advanced deep learning models? Because what I have seen is more of object detection from the satellite imagery. Like, do you develop models that can be able to give out decisions? Like, I give it a satellite imagery of a place that has been affected by wildfire, and it tells me from the previous, like the land cover that was there, this is the amount of land that has been consumed by fire. So do you have like that innovation in your company to be able to have like the interactive models that are maybe oriented to the real world? Thank you.
Thank you for the question. This would not be in the place company because we are providing the image you're building or you're applying your algorithms on, but I've seen when Pauline had this toolbox open, buildings is one of the things that you can detect. There were trees, probably fires. South Africa must have them. And David Gadsden mentioned this morning, Esri employs 10,000 people. You can trust that somebody tried something like that. And that doesn't mean that at technical universities you shouldn't also try to do your own models. Esri doesn't do everything, but there is quite a bit or a big part of Esri doing research on advancing technologies. Check what they did and do what they don't do. Add on to that. That would be my advice. Pauline, you have more. Yeah, please.
Yes, just tied to the first slide I had initially. I think I had highlighted some of the things that would be possible with machine learning, again, through Esri. Some reason this is not, oh, okay. So just to answer you quickly, but again, we can have this discussion at our booth. So you're able to extract information, but you're also able to make predictions. So we have those models, as he mentioned, that we'll be able to do that, as well as to do the kind of analysis you have in mind, because there's what Esri has built, then there's what we are leveraging from other providers. Yeah, so it is possible. Yeah, I hope you can pick this up after.
Thank you. Thanks a lot to Rcmrd for giving us the big stage. To the audience for staying on and for having a lot of questions. And last, Pauline, for you, support. We were the first time together on stage. Pauline did a good job. Great. Thank you all. We want to close here, and you know where to find us. Thanks.
Thank you, Pauline. I know why you've not clapped. Can we have another round of applause, please? To Caspar and Pauline. And the reason why you didn't clap the first time is because you wanted to be here so that you do the presentation. And the second one will be the partnership that they have, the sync that they had. It was meticulous. Thank you so much, Caspar and Pauline. Once again, a round of applause for them. So this is exactly what the RIC is about. It's about creating partnerships. If the gentleman from TUK can engage Caspar and Pauline and come up with exactly what he's been saying, for Rcmrd, we say, let it again happen. So we are here to learn. We are here to create partnerships. We are here to create opportunities. We are here to network and grow together and eventually build friendships. That is the main reason why we are here. And for that, I have a few announcements that I like to make. And the first one will be, please, our booths are still open. The conversation that we've been having here can still continue inside the booths. We have the poster sessions. We had them at the breakfast session, the other side. But again, we still have an opportunity. They will still be presented in our breakout sessions. And tomorrow morning, they'll be at this particular place, in between the plenary and the booths. You still have a chance to talk to the presenters and get to know more. For the guys who are asking about the program, please, if you go to either App Store or Play Store, you type Rcmrd International Conference, you'll be able to download the Hubilo. The program is there. All the activities that are going on, you'll be able to access them there. We have announcements there. We have an opportunity to vote for the best booth. I don't want to say, you have an opportunity to vote for the best booth, and you have an opportunity to give us the feedback so that we can improve on the next and the next sessions of the RIC. For the venues, we still have the same. This particular holding room will be having the lands. The one in the complex, second floor complex, innovations and data. Complex ground floor, the conference hall in the ground floor at the complex will be having biodiversity and food security. Biodiversity and blue economy. The RCTI conference on the other side will be having agriculture and food security. So please be aware. And then the lunch venues still same places. We have the rest of us having this side, and then dignitaries here. Bon appetit. Thank you so much. So once again, lunch will be served